Hello everyone, I'm going to give you a video demonstration of the data manipulation exercise. You want to fork this repository. This is on my GitHub account. You want to go to the GitHub account and click on fork, and that will put a copy on your GitHub account. And then you want to switch over to your account to work on this assignment. You can download the files. I've showed a couple in ways to do that in past videos, but here you could just do download zip and download the zip file, and once you have that downloaded, you can extract it, and I've already done that, and here are the here's the extracted files. And again, you want to open up your instruction sheet. This is the answer sheet, and that will have the steps you need to go through to complete this assignment. So we've talked about things about in number 2 and number 3 in past videos. So you want to go to your previous assignments to look up that information. What are important steps we complete? Again, that's going to be on the week 2 assignment. And now we want to go open the week 3 RDS file in Jamovi. So we can take a little look at this RDS. You'll see we have a new data format or new file format .rds, and that is an R data file. So Jamovi, we have previously opened up CSV files, we've opened up Excel sheets, and we've opened up an SPSS data file, a .sav file, and this week we're going to open up an R data file, which is the .rds file. So we're going to go to Jamovi, and I have that hanging out there. It's going to take a second to open up. And I'll probably go through this pretty quickly. Feel free to pause the video or go back and listen to parts over again. To open the RDS file, we're going to go to the File menu, which is these 3 horizontal lines on the left-hand top side of the window, and go to Open and Browse. And we're going to go back to our downloads and look at data manipulation, and there's our week 3 RDS, and open that. And you see we have a bigger data set, so we can look through. Let's take a peek at our instruction sheet, see what I asked you to do. Look at the variables in the data set and the level of measurement for each one, so you probably want to make a note of that on your paper to be able to answer the questions. Make sure the levels of measurement for each variable are correct in Jamovi. So if we go look through our data set, again, we can make sure those are correct by clicking on the column header with the names, and we can look at that. So we have a variable called sex with male and female. That's nominal. Research, qual or quant. That's nominal. That looks good. Height. This is probably height in centimeters. So let's put a little note to ourselves that that's in centimeters. That is a ratio level of measurement, so continuous is correct for that. Weight, that's going to be in kilograms, so we can put a note on that one. And that's going to be ratio, and that's going to be continuous. That's correct. And I have a made-up data set here, a made-up instrument. And you'll see I've got 4 variables called LVST1, LVST2, LVST3, LVST4. This is my made-up love of statistics scale that has 4 questions. And then you're going to see there's 3 variables, an FRST1, FRST2, and FRST3. This is my made-up fear of statistics scale. So if we look at LVST1, we see we have some text here, moderately, a little bit, moderately, a little. And you'll see that because this is an R data format, I already have this in the proper order, so it goes not at all, a little, moderately, mostly, completely. So those seem in ordinal level. You'll see though it's called nominal. Let's go ahead and change that to ordinal. So that looks good. If we go to our next variable, you'll see it's the same scale, and again, that shouldn't be nominal, it should be ordinal. And if you have any questions about why I have put these this way, make sure you come to office hours or post in the discussion board to get that clarified, because understanding the level of measurement for the variables is very important. It determines what statistical procedures we can perform on the data, and basically what we can do. So, okay, so I'm pretty comfortable with the level of measurement being set in the data set. Here's a good example where, we can do a little visual inspection. We can scroll down, but there are a lot of data there. It's kind of hard to tell if, we can maybe see some missing data, but it's kind of wide also. We have to do this in parts. So this is where, a visual inspection is okay, but it may be a good idea to actually look at the descriptive statistics and look for any problems. So to get descriptive statistics, we're going to be in analysis. We're going to go to exploration and descriptives, and we can do our categorical variables first. So we can go ahead and do sex, research, and we can do all of our questionnaire variables. And if you click on the first one and then go down to the bottom one and hit shift, it will click all the variables in between there. And you can either hit the arrow key or drag them over, and you'll see now we have all these variables listed. And again, these are categorical variables, so we really care about the frequencies and percents, and we don't care about means and standard deviations. And you'll see now we have all of that stuff. And let's go ahead and get plots. And these are categorical variables, so we want bar plots. So as we look through these, I'm looking for missing data. You see that none of those variables have any missing data. Up here in missing, we have 96 observations in all the variables. And now if we go through each variable, you can see the levels of each one and how many, frequency and percent. And I don't see anything that looks, out of the ordinary. Everything looks like it is spelled correctly. I didn't see any extreme values in there. So this is definitely something you want to take some time and look through. I have looked through these. I'm familiar with them. But when you go to a new data set, you want to just take time and look at each variable individually. Look at the descriptive statistics. Look for anything that's misspelled. Look for anything that's extreme or anything that's missing. So that's important. And we did, I guess the one thing we did find was that the levels of measurement were set correctly, so we had to fix that in here in Jamovi. And then part of looking at that is we can look at the bar plots, and you see they're not all distributed exactly the same, but also nothing seems crazy. And now we can get descriptive statistics on our continuous variables. So we can go back to analysis, click on exploration, and pick descriptives, and you'll see that it moves us to a new part in our output. And this time we're going to get our continuous variables, which are height and weight, and drag those over. And this time we're going to keep our mean and medium. We can go ahead and get our skewness and kurtosis. We can go ahead and get our range. Those are all nice things to look at. And let's go ahead and just get a normality test on these. So again, we can see we don't have any missing data. We have means and medians here, standard deviations. You'll see that we have a pretty decent standard deviation on some of these. So there's a bit of a spread there on these variables. You can see a minimum and maximum, and you can see that it's a pretty big range on the height and the weight also. So looking at this one, 9 kilograms, that is pretty darn low. So let's go back and look at, we didn't get our plots yet, so let's go ahead and get our histogram and our box plot. And you can see we have something down there on the bottom. So I would definitely want to go and check that outlier out. Who weighs 9 kilograms? So that could be, you know, it could be a data entry error. It could be somebody with, you know, whatever reason. Do we end up with a child in the data set? Definitely worth checking out. So, you know, here we don't know. We're just going to go ahead and run this analysis like we, you know, don't know what it is, or you would have to justification why you kept it in or left it out. We're not going to do anything in this case, but I would probably, if it were me and I didn't know why it was so low and I couldn't figure out why, you know, I would go check the original data. I'd probably drop that individual from the analysis because it really does seem to be quite a bit less than the other observations. So that is something you'd keep in mind as you go through this. Okay, so we did check the data set and noted any problems, and we do have that one weight, which is pretty low. So we're going to create a new variable in Jamovi for BMI. And I gave you the formula for BMI. It is weight in kilograms divided by height, height in meters squared. So this is a situation where you can kind of decide how you want to handle this. Our height is in, if we go look at our data and we see our height variable, you'll notice we have this in centimeters, but to use it in the formula, we need it in meters. So we can either create a new variable and switch it to meters, or we can manipulate the formula. So sometimes it's easier to do things in steps. So I'm just going to go ahead and create a new variable that's in meters. And in this instance, I'm going to take height and I'm going to divide by 100 because we know there's 100 centimeters in each meter. So we're going to change this height in centimeters to height in meters. So I'm going to pick compute. Oh, never mind. I think I'm going to do, let's do transform. Okay, so you'll see it gives us this height too, and I'm just going to change the name of this variable. And if I could type, change that to height in meters, and we can give it a manipulation here. So we're going to say create a new transform, and we're going to take our source variable, just how it is, and divide by 100, and let's see what that does. So you'll notice that now we have height, and we have height in meters, and that changed our variable from that. And let's see if we can get rid of, let's delete variable, we made a mistake, delete column D, yes. Okay, so now we have a height in meters. So now we want to compute a variable, and I'm just going to put it after the weight variable. So I'm going to go back to compute, and we're going to call this BMI. And I think Jamovi makes this pretty easy. I think we can just use the variable names here. So again, our formula was weight in kilograms divided by height in meters squared. So our weight in kilograms is just weight divided by, we can go height in meters, so height meter and use our exponent squared. And let's see what happens. And I called it height meters. So let's go back to our variable and fix my spelling and hit enter. And now you see we have a new BMI variable that is calculated from these variables. So not too hard to do. Again, this is something you can look up in the user's guide or look online in Google if you're not sure how to do it. That's how I figured out how to do this. But calculating variables and transforming variables is something that you may very well need to do with the data set. So let's go see if I have you do anything else in the Jamovi data set. Okay, create a new variable in Jamovi for the level of stats 4 recode. So what we want to do is change high values to low values, and here's what I gave you. If it's a 1, it's going to go to a 5. If it's a 2, it's going to go to a 4. If it's a 3, it's going to go to a 3, and a 4 to a 2, and a 5 to a 1. So this is another transformation that you might see. It's called reverse coding. And maybe they use it in questionnaires to keep people from just filling in the same answer on everything. Sometimes they might orient something in a different way, and this is an example of that. So we're going to transform love of stats 4, and we're going to reverse code it. So I'm going to go back to Jamovi, and let's go to our love of stats 4, and we're going to go do a transform. And using transform, we're going to make a new one. And this is kind of a little trick when you have things that are ordered by numbers 1, 2, 3, 4, 5 sequentially like that. You can actually take one more than the max value and subtract all the other values from it, and it's going to do the transform for you. So I know this is a scale of 1 to 5, so I'm going to say take a value of 6 and subtract the source value from it, and give me the result. And this does the transform. And I'll let you go do some checking if you want to see if that really works. But that is one way to do that transform. And that's pretty easy. All right, let's see what else I asked you to do. Now we're going to save our Jamovi file, and we're going to export our output. So back in Jamovi, we're going to go to File menu, which looks like the 3 lines, Save As, Browse, and we're in our data manipulation and week 3 OMV. That looks just fine. And something that I didn't show you guys before is you can actually go back and select different parts of your output if you made a mistake. And in this case, where's our old descriptives and our new descriptives? Oh, I'm going to get out of this, get out of that, and now we're back in analysis. Now you'll notice that part of it is darker and part of it is lighter. I can actually change any of these analyses by clicking in the part that I want to change. So you'll see up here I'm back in my categorical variables. I could go change any of these settings and it will update that output. If I go down here to my continuous variables and I click in that part of the output, I can go, it takes me into that part and I can update this. So that's kind of handy. There's other statistical programs, namely SPSS, where every time you do something new, it just tacks it to the bottom. And it's really a pain when you make a mistake and you have a whole bunch of output. So that's something handy. Okay, now we're going to export this. So we're going to right click in the output, and we want to go to, we can either export this one analysis or we can export everything. So we're going to go to all, and we're going to go to export and browse, and we're in our data file. If we weren't, we'd go there. We're going to say data manipulation output, and hit save. And now if we go look in our assignment folder, we should have our OMV file, which we do, and we should have our data manipulation output PDF, and we do. So we've done the things in Jamovi that we needed to. And our instruction sheet next tells us to navigate to our assignment folder and open the RMD file. Note any difficulties. So we're going to go back to our assignment folder and go to our there is our RMD file for our R notebook, and we're going to open that with RStudio. Okay, and we can see this actually kept us in our other thing, so I'm going to go change the session on this because I had other files open. So I'm going to go ahead and close these other files just to clean things up a little bit. And I'm going to go switch my session, change my working directory. I'm going to choose my directory, and I'm going to go to Downloads, Data Manipulation, and hit Open. Okay, so here is the correct folder that I wanted in my files. Here's my R Markdown document, and there's my RDS, and there's my saved OMV, and here's my output, and my answer sheet. So this is the one I want. So we're going to go through this R notebook, and again, this is set up as an R notebook, and it's going to give us GitHub Markdown as the output when we're all done. So we're going to go through this, and this talks a little bit about some manipulating data. We're going to get our packages list. We're going to install any if we need them, but we knew we already installed them earlier, so this should go fast. If you haven't got these installed, this is going to take several minutes. You just need to let it run and do its work. And then we're going to load each package into memory by using the library command. Okay. Opening the data file, here we've got our week 3 RDS file listed, and since we switched into the right working directory, it should find this just fine. So let's run it, and you'll see now we have our data set. It says 96 observations of 11 variables, and again we can take a look at that in RStudio also by clicking on that, and that executes the view command down here in the console, and we can look at these data. Again, you can do a visual inspection, but looking at descriptive statistics is probably easier when the data set's kind of large like that. We can click on the tab to go back to our notebook. We're going to look at the data set, and you want to note on your instruction sheet, again, this is a good place to read through your answer sheet, and we're going to look at these different variables and what levels of measurement we should have. So it looks like we're going to be calculating some of these variables, and we're going to do that here in our notebook. You don't need to put any answers here in the R notebook. That was there from before when I first created this assignment. So we're going to calculate a new column. So here's our BMI. We're going to make our BMI variable, and here in this R example, you'll see I'm making a new variable called BMI, and I'm going to use weight divided by height, and here I don't bother to create the height in meters variable. I just manipulated this in the formula directory, so you can do it either way. Is easier for you, but now you've seen a couple different ways to go about getting our BMI variable. And we ran this, and you saw that it executed down here in the console. If we go back to our data set and go over to the right, you'll see now that we have a new BMI column right there. And I did make that a little prettier by rounding it off to one decimal place. There's not not too much reason we would need 2 decimal places or more on that. Okay, we can reverse code columns in R like we did in Jamovi. So I give you an example here, and you can, I left some text there, you can read through that and see that, but we can run through this and use that trick we did before by subtracting one higher than the max value, our values from that, and it's going to give us that. And if we look in our data set now, you'll see that we have our reverse coded column right there. And we're going to score this instrument. So I do give you some extra information in this R example of a couple ways that we can score things. We can either add all the items together, you'll see that often, or you can take an average of the items. And adding them all together is probably easier to do because you're just taking a sum. But taking an average of items makes it a little more interpretable. We know that it's on a scale of 1 to 5, and if we added them all together, all of a sudden we're going to take 4 variables, and if they all answered on 1, that'd be 4 ones added together, and if they all answered 5, that'd be 20. So we end up with a final score ranging from 4 to 20, as opposed to averaging it. It's still going to be on the same scale of 1 to 5. So you can kind of choose how you do these things. We're going to see that it actually does not affect the statistics which way you do it. So we're going to I think we did our reverse coding already, but it doesn't matter if you run it again. And we're going to score our fear of statistics scale, and here we're using addition on these things, so we're summing them. And we're going to do final scores using averages. So if I got this correct, there's our love of statistics and fear of statistics totals, and our sums, and our love of statistics and fear of statistics averages. And so you'll see we have the numbers look quite a bit different. One thing that we talk about this week is z-scores, and that is standardizing. And z-scores allow us to compare things that aren't really similar to each other. So in this case, we have these fake scales, and we had 4 questions in the love and 3 questions in the loss, and so it really doesn't make sense to compare these numbers directly with each other. And also they're measuring different things, so the units technically aren't the same. So a z-score, if we change these to z-scores, it actually changes the units from the original units to standard deviation units, and then we can do an actual comparison between things even though they're different. So I gave you an example here of how to calculate z-scores, and we're doing it on both of the summed totals and the average totals. So we're going to run that code block right there. And one thing you're going to notice is that when we have our love of statistic and our on the sums and the love of statistics on the means, you'll notice those z-scores are exactly the same. So it doesn't really matter if you sum the instrument or you average the instrument, you're going to get the exact z-scores, and the statistics you run on these things are not going to be changed. Same thing on the fear of statistics. You'll see that the summed and the average scores give you the exact same z-scores. So pretty interesting. It's pretty useful. These things are definitely worth learning how to do them and what they do, because they're very useful in a lot of situations. So I will leave it to you to work through the questions in your answer sheet. There's a couple questions about what these things mean on z-scores and why are z-scores useful, and the impacts of summing and averaging, And also there's some questions in here about z-scores with an absolute value greater than 2. So look at those variables and see if you can figure out how to find the high and low z-scores, and because you're going to answer those questions on your assignment questions. So after we have done this, we're going to knit this to a markdown file again. So let's go ahead and go back into RStudio, and we will go to our R notebook, and we'll go to knit and markdown, and this takes a minute to run. Should just let it do its thing. And let's see, did we get our... We did. So if we look in our file, we see we have a new markdown file, so it saved it in there for us. Okay, we can close this pop-up, and we can close RStudio. I don't care about saving the workspace image because we already saved our file that we needed from it. And now we can go to our repository and add file and upload files, and we can drag our Jamovi file over, our markdown file over, and our PDF of our output from Jamovi over. And you guys will click the commit changes to save all those into your repository. I'm going to hit cancel, and then you can copy your repository URL and turn that in Canvas for your assignment. I hope you have a good day. If you have any problems or questions, come to office hours or post them in the discussion, and we can try and help you out.